Okay, we're moving on to section 11.5. There's really not a lot of new material in 11.5. There's two parts to it, but they're really just a continuation of previous material. We're working with arc measures here on the first part, and then as we flip over to the back side, we will work with arc length. So let's talk about the first theorem here. The first theorem basically says that if a quadrilateral is inscribed in a circle, then the opposite angles are supplementary. So let's talk about this. If I look at angle A here, then I know that that angle measure is half of that arc there, because the vertex is on the circle. And if I look at angle C, which is the opposite angle from in this quadrilateral here, I can see that this angle right here is half the length of, or half of the measure, excuse me, of that arc right there. And can you see that the measure of the blue arc and the measure of the red arc together add up to 360? So that means that these two angles, if they're each half of the measure of the arcs, then these two angles have to add up to 180 degrees, half of that. And so they have to be supplementary to each other. Supplementary. Okay, and let's try one problem just to kind of go through that. If I have a quadrilateral inscribed in a circle here, I know that this angle is 135. So I know that this angle across from it, the opposite angle, has to be supplementary, or it's going to be 45 degrees, which also means that this arc right here must be 90, because this is going to be half the measure of this arc right here, because it's an inscribed angle. And so if this is 90, then I know that from this point here to this point here has to be 50 degrees. And then to find the measure of angle A, we know that that measure of that angle is going to be half the difference, because that angle is outside of the circle, right? This is from the last section. It's going to be half the difference. And it's going to be half the difference of the 50 degree, let's see, the angle is eating this arc right here, as well as the 50 degree arc right here. And we know that this arc right here must be 310 degrees, right? Because the two angles have to add up. This arc right here, 310, and this 50 have to add up to 360. And so I can do 310 minus 50 divided by 2, half the difference. And so I'm going to end up with, I think it's 130 degrees. And that's it. I'm going to flip over to the back side and we'll talk about arc length. Okay, so the back side of this thing is talking about arc length, which we have talked about earlier in the chapter. We're going to continue doing that right now. And so we know that arc length, by definition, is the measure of the arc divided by 360 times the circumference, or it's the fraction of the circumference. Fraction of the circumference. So let's take a look at the first problem here. Find the exact measure and length of arc AC. So I'm looking at this angle right here, which is a right angle. And it tells me that this right here, this arc right here, is going to be 180 degrees, right? Because this angle is an inscribed angle. It's half of the measure of the arc that it's eating. So that means that if I draw a segment from here to here, that has to be a diameter, right? Because it's going to be a semicircle. 180 degrees right here, semicircle. So I know it's a 6, 8, 10 triangle where these each are 5 and 5. So I know my radius is equal to 5. And so let's see, we've got the exact measure, which is 180, and we are looking for the arc length. So it's going to be the measure of the arc, which is 180 divided by 360, or half, right? 180 divided by 360 is a half of the circumference, which is 2 pi r, 2 pi times 5. Or it's going to be half of 10 pi, or 5 pi is going to be the arc length. Problem number 2 here. The length of the arc xy is 9 pi. Okay, so we're given the arc length in this particular case. So I'm going to use the formula, the measure of the arc, divided by 360, times, I know that zy is the radius, and it's 12. This is the radius. So I know that pi d is going to be 24 pi, or 2 pi r. And that's going to be equal to 9 pi, which is the arc length. I'm going to go ahead and solve this thing for the measure of the arc. The pi's drop out. Multiply both sides by 360, divide both sides by 24. I get that the measure of the arc is equal to 135 degrees. So this measure of arc xy is going to be 135 degrees, which makes this, because this is a semicircle, remember it goes through the center, makes this 45 degrees right here. And now if I want to find the measure of angle A, again, this angle is on the outside of the circle, and it's going to be the difference, it's half the difference of the intercepted arcs. And so I'm looking at this arc and this arc right here as my two arcs that are intercepted by that angle. And so I'm going to get 135 minus 45 divided by 2, half the difference, and I'm going to get 45 degrees as my answer for angle A. Alright, problem number 3 here. Let's just try a couple of these. It says that the arcs are drawn from each center point, so these are center points of these circles, and these are all equilateral triangles. So I know this is 12. Since this is 12, this is 12 also, so these each have to be 6. So I know my radius in this case is equal to 6, and I'm looking for the length of each of these arcs. Well, the arc measure is going to be 180 degrees in this case, so it's going to be 180 divided by 360, or half of the radius is 6, so it's going to be 12 pi d, and so the answer is just going to be 6 pi, half of 12 pi. And let's try this one right here. We'll say that this is the last one we'll try here. I know that this is 12, this is a 60-degree angle, this is 12, this is 12, these are all 12. I know my radius in this case, because this is the center of the circle, and this is, you know, part of the arc of the circle. My radius is going to be 12. And so I can go ahead and plug into the formula. Measure of the arc is 60 divided by 360, or 1/6 of, I'm going to use the radius here, 2 pi r, 24 pi. So 1/6 of 24 pi, which is just going to be 4 pi. And that's it. That's the length of the arc in this situation. This right there, that arc. Okay, I think I'm going to stop right here and let you go ahead and try some of the assignment. All right, take care.